Today we're looking at major updates to the Universe Sandbox simulator. Right now, we'll go through it from start to finish. We'll see what the developers added, how it works, and test it all in real space scenarios. Just so you're sure, I'm showing you that I have the latest version of this simulator installed, and the first new feature we'll look at is the improved lasers. Basically, the developers updated the laser, which now allows you to destroy several objects at once instead of just one. And now we'll test this out using 3 Earths as an example. For instance, I'll fire the laser like this here and like this here, and we see that the laser actually hits several objects at once. That sounds great. Now when setting up the lasers, I'll go ahead and choose this powerful Galactic Empire super laser. On those, well, let's test it out. I'll do this again and aim it at those Earths. Look at how it hits right here and right here. Well, that's cool. So you get the gist of this update. The developers also show quite clearly in their patch notes that you can now break apart rings using this laser. Just look at that. It looks really cool, wouldn't you agree? This definitely wasn't possible before. It looks amazing. Kudos to the developers for this, seriously. You can actually destroy Saturn's rings in this way, and really any rings of any planet in this simulator. And the developers tell us that we can even move objects using the laser. And to be able to move them, you need to increase the light radiation pressure in the laser settings. See, this object currently has a perfectly circular orbit around the planet. This is a moon of the planet. Let's try to knock it out of orbit using the laser. I'll just crank everything up to the max here, like this, and try to fire it. Oh, see, I can use the laser to change the axial tilt of this moon. I managed to change its orbit. So, guys, using this radiation pressure parameter, we can actually move objects and change their axial tilt and so on. Now, the next new feature is a very good one. They write, thanks to our new atmospheric drag model simulating meteors, objects now burn up as they pass through planetary atmospheres. Trails form as volatile substances, such as water, burn off the object. Well, let me restart this simulation one more time. So, we have 3 seconds passing per second in the simulator, and we see meteors entering Earth's atmosphere. There they go, flying along. I mean, you have to admit, that looks so cool. And now an explosion is about to happen. Oh, we have the space goggles off here. If you put them back on, it all looks like this. Just gorgeous big thumbs up to the developers for this new feature. I'll show you how they fly and how to launch them to get this effect. As you can see, they're launched at a very shallow angle relative to the Earth. So, to get this effect, we need to launch the asteroids exactly like that. Look at how cool that looks. Let's move on to the next new feature, and I think this feature is the best and most successful one in this update. Basically, they've added object stretching and squashing, and they write that it's a simulation of real-life object stretching and flattening under the influence of gravity or rapid rotation. Right now, a day on Earth is almost 24 hours, but if we decrease this value, reducing it like this further and further, down to a 2-hour day on Earth, look at how the Earth has flattened out quite significantly. So this is all real, exactly how it should be in real life. The new feature is just gorgeous. If we were to suddenly re-establish a 24-hour day on Earth, this is how the planet would recover. Well, you have to admit it looks absolutely awesome. Say, a day on Earth is 1 hour, then Earth will already start losing its matter. Something like that, guys. This doesn't just work with Earth. We can flatten any objects in the solar system and beyond. Take Jupiter, for example. Its day is currently just under 10 hours. And if we set Jupiter's day to 4 hours, it flattens too, but it's wobbling like this for now. If we speed up time, everything stabilizes and it will just have this elongated shape. It looks cool and pretty neat. And as you've realized, this works with stars too. Right now, the sun has a day of 26 Earth days. Well, let's set a 10-hour day on the sun. And now 5 hours, and after a while, the sun stabilizes and looks like this. Now let me take Mars and place it close to Earth right here. So Mars is very close to Earth, and now you'll see how Earth's gravity starts to compress it, so to speak, stretching it as time speeds up. Ah well, the Roche limit is at work here. Well, you can see for yourself that Mars has already stretched like this, and so you see this is what Mars became after being so close to our Earth. And now I'll show you using Jupiter and Uranus how Uranus starts changing its shape as it approaches Jupiter. This is going to be a direct collision. Well, you can already see with the naked eye that Uranus has stretched significantly, so the effect of stretching by tidal forces now works much better. And that's how Uranus in fact collides with Jupiter. Now for the next new feature. We can adjust the thermal glow and brightness of any object, even items. That's exactly what they tell us. Like, take a whale, for example. Let's take a whale, for example. So here we have a sperm whale. We need to go into the visual view, and there's a specific feature right here called thermal glow. We can expand this menu section here and manually configure a custom configuration. And then there's this thing called called luminosity. And for instance, we can even adjust the solar luminosity and just give this object one solar luminosity. And here, of course, we need to change the color. We can set a glow, say a blue whale like this, with the luminosity of the sun. Look at how cool that looks. And if we change the color, say to something like this soft pale yellow, like a properly realistic star, well anyway, something like that, guys. And now, for instance, let's try placing Earth right next to this object, just to see what happens. Well, let's say I'll put it right here. Here's the whale. And here, in fact, is Earth. And this whale is illuminating Earth with its glow. I'll even turn off this artificial directional light in the simulation settings. And now we see how this whale illuminates Earth. Well, amazing. And let's say we change the whale's color once again to this specific shade, and Earth will be illuminated in that exact color too. White. Now moving on to the next brand new feature, they've added this interesting thing called tidal locking. We now have the unique ability to model complex situations where a planet's moon will gradually become tidally locked over a period of time. Well, this applies to all objects, not just satellites. Venus has no natural moons, so I suggest we give it one of its very own. I'll give Venus a small moon, placing it about 30,000 kilometers away. As we see in the moon's stats, its orbital period is exactly 16 hours, while its day is currently over 13 hours. Let's even set the length of its day to a total of 100 hours. Anyway, I'm starting the simulation at 1 day per second. And yes, we see the day on this moon starting to speed up. Yeah, 80, 70, 60, 50. I'll speed up time more. Now it's 1 month per second. And now the day has sped up to 18 hours, getting closer and closer to 16 hours. And we see the numbers starting to slow down here, speeding up time again. And it's almost 16 hours now. So Venus is tidally locking this moon quite quickly. Well, as you can see, tidal locking has occurred. The orbital period and the day on this moon are now perfectly equal. Now let's take a look at another new feature they've added, Lagrange Points. Lagrange Points are special spots in space where the gravity of two large bodies, like the Sun and Earth, balances out so an object can orbit with them and stay in a stable position relative to those bodies. To add Lagrange Points, navigate to Earth's properties, and here in the General tab, expand all the sections. And there's an option to add Lagrange Points. Simply click it once and you'll see 1 point added, followed by a second point. But there are actually 5 Lagrange points, and the others are located along Earth's orbit like this. Here you can see point L3, point L4, and point L5. Now I'll explain how to use these points. Go into the properties of the point you want. I've opened up point L2, and there is a handy button right here to place an object at that point. I chose Lagrange point L2 for a reason, as that's exactly where the James Webb Space Telescope orbits. So let's try to place it there. I'll go to Objects, and here is the Space Telescope, placing it there now. For those who wanted to experiment with these points, you now have that opportunity. I assume we can add these points to all objects. I'm adding them to Mars now. And yes, we see that Lagrange points have appeared for Mars too. Now for a new feature. These are predicted trajectories. The developers say this feature lets us see an object's future path, and if a collision is detected, the trajectory will change color from yellow to red. To enable these predicted trajectories, we need to go to the View menu, and you can find the button right here. Click it, and everything is enabled. I'll put the first one here, the second one there. See how it works? It's showing red all the time. Oh, absolutely everything is bright yellow here. I still need to understand exactly how it works. This feature appeared, but I don't quite understand how it works just yet. Anyway, you can figure it out yourselves and let me know in the comments. The next feature added by the developers is gravity fields for non-spherical objects. To enable this feature, using Earth as a primary example, first go to the Motion tab, scroll almost all the way to the bottom, and just above the Magic tab, you will find an option for non-spherical gravity. It is turned off by default, but you can easily activate it and then choose your preferred simulation mode, which is set to realistic, or you can manually set it up yourself using the custom mode. They've also added some new viewing tools for us. When adding objects, you can automatically enable orbits, the simulation grid, or the display of the habitable zone. Let's say in your simulation, the orbits are currently turned off, just like this. First, you go right here to the Add tool, then switch over to the View tab. And from here, you can easily configure the grid display. For instance, you can turn off the grid. You can enable automatic orbit display and the habitable zone display right here. See how that works? Say you take Charon, place it here, and then you just close it. And once you close it, everything automatically reverts to how it was set before adding the the object. When you enter this mode again, the habitable zone and orbits are automatically activated. You can turn it all off here and it won't be displayed anymore. So that's a new feature. I think it's quite convenient actually. The next thing they added is new overlay parameters. So let's head over to the View tab and take a look at these new items. I've already mentioned the predicted paths, but there are actually two more very interesting items here. I'll show you exactly how they work using Earth as an example. There's an axis lines button right here, simply activate it and we can see all of Earth's various axis lines. Pretty interesting, right guys? And there's also a tidal lag button now. Activating it, we see this yellow trail appear behind the Earth. Turning it off, then on, see? Now let's see where this line is pointing. It's pointing right at the sun. It turns out the sun affects the Earth with tidal lag. They've also updated the save file structure. They say simulation and object save files are now significantly more versatile and functional. And the final addition to the feature set is number formatting. You can set the digit separator however you prefer, commas, periods, spaces, or no separator at all. By default, it'll use the number format that matches the language selected in the simulator. My simulator interface is in English, so my separator is a period. In your case, it might be a comma or a space, but if you don't like that specific style, you can easily change it to whatever you prefer. To do this, simply go to the main menu, open up your settings, select General, and then find this specific number formatting tab right here. Here, you can change the group separator. Just pick whichever one you prefer right here. There's also a decimal separator option. You can choose that too. Here's a comma, and here's a period. See, it changes right here. Once more, 1 comma, 1 period, and you can choose scientific notation here. You can see the powers, either the standard power format or these other formats. So the developers have given us the ability to customize it like this. That's what the new Universe Sandbox update looks like. If this video was helpful or interesting, give it a like and tell us in the comments what you liked most. Thank you very much.